Hello guys, it's recording. So welcome to our lesson 7. So this is the second topic for our second grading. So guys, come with me. Madali lang to. Kayang-kaya natin to. So our topic for today is chi-square. There are actually 3 types of chi-square, and the type that we're going to focus on, the one that we will compute, is goodness of fit test. So class, our objectives for today. So we want to understand if we're given a set of data, if we're going to use chi-square or not, to accurately interpret the result of the test statistics class. This is going to be like hypothesis testing again using categorical variables, and we will solve for chi-square. Yeah. So class, when we talk about chi-square, the variables are grouped into categories. Yeah. Your variables are grouped into categories. Ma'am, like what categories? Example, blood type A, blood type B, blood type C. If the person is smoking or non-smoking, or smoker or non-smoker, their BMI, their weight. So class, when you want to compare the relationships of the different categories, the different races, ganyan, it's best to use chi-square. So it's a fancy x squared. Actually, mas fancy pa yung x na yan. Yan, used for testing relationships between your categorical variables class. So usually, these categorical variables will be represented as a contingency table or cross tabulation. So class, meron tayong rows and columns. So example, on this photo, yan, this is found in your module. So frequency distribution of mean diastolic blood pressure for adults 30 to 69 years old. So class, they group the adults based on their ages. So people who are less than 50 years old. Ano ba to? They group the blood pressure they group the results of the blood pressures. So less than 50 of the diastolic. Yan, diastolic less yung nasa taas ng blood pressure. Kunyari 90 over 120. Yan, more than 50, less than 60, ganyan. So they grouped it based on the result of the diastolic pressure, something like that. So class, when do we use chi-square goodness of fit? So class, these are our conditions that should be met. If not class, wag mo lang gamitin ng chi-square. Number 1, if the sampling method is simple random sampling, so you acquired your sample through randomization. Next, the variable under study are categorical variables and class. So may categories na group sila into categories. And the expected value of the number of sample observation in each level of the variable is at least 5. So class, dapat more than 5 yung mga observation. Kasi kung less than 5, hindi mag-work ang chi-square. Yun. So mga 4 lang, ganun, or 3. It won't work. We need a higher number of observations. So dapat mas malaki yung sample. Yan. So we have 3 types of chi-square testing. So this is what we're going to focus on, goodness of fit. So basically here, we're going to compare theoretical categorical observation versus observed categorical observation. Basically, we want to answer how well our theory fits to the actuality. So the given class, you will see that there are observed values and expected values. So class, yung observed value, yun yung observed categorical observation, and we have expected values, which are your theoretical categorical observation. So we are assessing how does the variables fit to our expected values. And anyway, marami tayong example ng goodness of it. Next class, test of independence and test of homogeneity. Actually, medyo may pagkapareho sila. At ang activity ng class sa laboratory is to identify whether to use goodness of fit, test of independence, or test of homogeneity. So when it comes to test of independence, when data comes from 2 or more independent random samples or treatment groups in a randomized experiment. So if you utilize different samples that are very different, ayan, mamaya pag-usapan natin yan. And next, test of homogeneity, way of determining whether 2 or more subgroups of a population. So here, guys, we are comparing subgroups within a population share the same distribution of a single categorical variable. So example, ano ba ang nabibigyan natin ng mga subgroups? Example, educational levels, whether you are high school, masterals, PhD, bachelor. So these are subgroups. So if you are comparing now subgroups, test of homogeneity yon. Pero here, test of independence, if you're comparing two random samples, yan. So that is your test of independence. Yan. So magbigay tayo, practice tayo. So this is the question, letter A. So is there a different pattern in the distribution of accidental deaths in a certain region compared to the pattern in the entire United States? Yan. So basically here, you are comparing a theory and an expectation, or yun, a theory. Ma'am, alin yung theory dito or expected value? Ang expected dito yung pattern in the entire United States. And the observed data is ito, pattern in the distribution of accidental deaths in a certain region. Basically, they are comparing theory, yun, dito, dito. Theoretical categorical observation and observed categorical observation. Yung theoretical dito, one more time, is the pattern in the entire US, and the observed value is the distribution of accidental deaths. Yan. So, ayun class. So, this is a test of goodness of fit. Yan. Does this data show significant different pattern in the distribution of accidental deaths in the particular region compared to the pattern of the entire US? Yan. So, pag nagko-compare ng expected value at ng observed value, goodness of fit yan. Next, for example, among people of different races, Caucasian, Asians, African, have same proportion of smokers to non-smokers. The different education levels have different proportions of Democrats, Republicans, and Independent. Class, notice there are so much subgroup that these examples are talking about. Yung mga subgroups, ano yun? Test of independence or homogeneity. Yan, homogeneity. Mga subgroups eh. So the subgroups are Caucasian, Asians, Africans. They're comparing the proportions of smokers and non-smokers, educational level. So they are, aside from educational level, kino-compare pa nila kung Democrat sila, Republican, or Independent. Yan, next guys. Yan. Comparison of the distributions of opinion about quality of life among heart attack patients in Canada and US. Yan. So they're comparing the quality of life among Canada and US. So this is a test of independence. So two random samples. Next, determining whether two categorical variables are associated with one another in the population. So, two categorical variable lang in a population, like race. They're comparing race and smoking, education level, and political affiliation. So, this is your test for independence. Yan, dalawa lang yung categorical variable, just like the one before, Canada and US lang. Next, this is a test of homogeneity. So, ma'am, paano nasabi? Ayun ang mga subgroups, bachelor, master, professional, doctorate. Yan. If you're thinking homogeneity and independence sound the same, yes. Actually, yan. Kaya medyo magiging challenging yung laboratory activity nyo. The difference is a matter of design. How is your test of independence designed? Observational units are collected at random from a population and two categorical variables are observed for each unit. Yan, dalawa lang, tag-dalawa lang. Usually, parang mas maliit na test itong mga test of independence. Yan. Observations are collected at random from a population and two categorical units. In the test of homogeneity, data are collected randomly sampling from each subgroup separately. Yan. They're grouping the people separately. Yan. So, homogeneity yan. So, mas maraming subgroups. Pag mas marami, usually, homogeneity na yan. Okay. So, just for your, para may bakus naman ako, guys. These are the two formulas that we are going to use. For test of independence and test of homogeneity, actually, we're not going to solve this. Mag-focus tayo sa goodness of fit. So, the expected value in your independence and homogeneity is row total times column total over the total number of your small n. Ano ba yung small n? Number of, ano ba yun? Total number. So class, sabi ko, nabanggit ko kanina that we use contingency table or cross tabulation. Kaya may row total times column total. Yan. And actually, pareho sila ng test statistics. So, observed minus expected squared divided by expected, the summation of it. Yan, i-add mo all together. Same thing with your goodness of fit. However, the expected count magkaiba. So, the total number of observed samples times proportion ang expected count. Yan, dito tayo mag-focus mamaya. Yan. So, class, so this is also your pre-lab. So, your laboratory activity 7, what you're going to answer is this one. So, ang goal natin is masagutan ito. Yan. So, a clinical trial was conducted among 1 to 10 years of age with prior symptoms of otorrhea comparing efficacy of antibiotic ear drops, oral antibiotics, and observation without treatment. So class, these children, yan, may prior symptoms na daw sila. So tatlo yung mga treatment, antibiotic ear drops, oral antibiotic, and observation. So goodness of it to. Children were seen at home by physicians at 2 weeks and 6 months after randomization. The primary outcome was the presence of otorrhea at 2 weeks observed by study physicians. The results are given in table 10.22. The results agree with the expectation. Yan. So class, do the results agree with the expectation? Children were seen home by study 2 weeks after randomization. Yeah. Okay, so your number of children, class, these are your observed data, and number of children with otorrhea at 2 weeks, these are your expected values, and these are your expected values. So do the results agree with the expectation? So class, number of children are your observed values, your number of children with otorrhea 2 weeks are your expected values. So I just want to point it out. And class, second part is you're going to identify whether the problem is a goodness of fit, a test for independence, or homogeneity. Yan. So, yung gagawin nyo. So, class, how would you compute it? Yan. So, steps on chi-square goodness of fit test. So, state the hypothesis, check the conditions. Yan. So, if it's random sampling, if it's at least more than 5, and so on, yun yung mahalaga, at least more than 5. And solve the chi and p-value. So find the p-value and state the conclusion. So now, let's solve using Google Sheets. New share. Okay. Nakikita naman. Okay. So class, let's start with your chi-square goodness of fit. So, paano yung mga steps natin? So, step 1, step 2, step 3, step 4, and step 5. So, just like before, so we're going to do hypothesis testing. Yan. So, this is our problem. So, problem 1, a visual artist researched 256 artists' zodiac signs. Does this group of artists fit the prevailing theory? So, this visual artist, guys, yung observed values niya dito sa table na to, yan, kinuha niya yung mga zodiac signs ng mga artists. So, Aries 29, Taurus 24, Gemini 22, 19 Cancer, and so on. Yan. So, does this group of artists fit the prevailing theory? Yung tanong. So, meron tayong mga expected values. So, class, the expected values, sometimes given siya, just like in your activity 7, sometimes hindi. Yan. So, pag hindi siya given, I'll show you how to solve it kung proportion ang binigay sa inyo. But for this one, given naman yung expected values. So, class, so first one is state the hypothesis. So, HO. So, your null hypothesis, there is no significant difference between the star signs or being an artist. Yan. So, class, ganito pinapakita yung goodness of fit na null hypothesis. So, P1 is equal to P2 up to P12. So, P1 is your proportion of Aries, P2 is proportion of Taurus, yan, and so on. So, ibig sabihin, they are equal to the prevailing theory. Yan. And class HA, so there is a significant difference between the star signs on being an artist. So, di ba pag alternative hypothesis, we use greater than, less than, or not equal sign. So yun na, P1 is not equal to P2, P3 is not equal to P3. So, ganyan po ipapakita ang mathematical symbol ng alternative and null hypothesis. So, that's our first step. Next, step 2. So, before proceeding to chi-square test, you have to assess your expected values. So, if expected values should be more than 5, yan. So, class, kung hindi given ang expected values, solve ang expected values by the total number of observation times proportion. Yan. So, mamaya magsasolve tayo ng expected values. But as of now, it's given. So, may nakikita ka bang less than 5 dyan? Wala naman. So, we can proceed to using chi-square test, and there are categorical variables. So, push na push tayo. Yan. And number 3 is test your statistics. So, your chi-square, its formula is summation of observed minus expected squared divided by expected value. So, basically, i-solve natin the observed minus expected squared divided by expected, tapos yung sum ng lahat. So, yun na yung chi-square natin. So, your observed values or observed counts are the actual number of observations of each type, and the expected counts are the number of observations that we would expect to see of each type if the null was true. Yan. So, class, yun, isolve na natin ang ating chi-square. So, walang ano dito, walang Excel na pag na formula to push for chi-square. Usually, P ang lumalabas. Anyway, so kailangan natin gumawa ng sarili nating formula. So, ako, ang kanya-kanya strategy class. So, sa akin, diretso na. So, equal sign. Don't forget the quantity. So, dalawang parentheses class. So, observed minus expected tapos quantity. Yan. So, copy na lang natin. Kasi diba, i-multiply niya daw squared eh. So, you will multiply it by to itself. Yan. Tapos, don't forget another parenthesis because, yan, dapat enclose sila and divided by expected value. So, press 40 again. Click on 40 again. So, yun na yun. So, 3.025. And just drag it down. Ayun. So, class, ito, nalagay ko na. So, dito, so you just get the total. So, equal sum. Yan. Yan. So, our total is 24.11. Yan. So, that's our chi-square, guys. Yan. So, mama na nang ginawa nyo. Ang bilis naman. So, ganun lang, class. So, equal sign. O, lagyan mo ng quantity na dalawa. Observed minus expected. Yan. Times. O, isa na naman. Kung ayaw nyo mag-copy-paste, observed minus expected. Kasi nga squared eh, di ba? Divided by expected. Yan. Ako, pag hindi magkapareho, lagot ako yan. So, 3.025. So, class, ganun lang, ha? Yan. So, our chi-square is 24.11. Now, is we're going to solve for our p-value. So, paano ba kunin ang p-value? So, we can use now a formula from your Excel, which is chi.inv quantity 0.95, comma, your degrees of freedom. View. Zoom natin. Ano yung makita. Yan. So, tapos na tayo dyan. Nakuha natin yung chi-square. Yan. Okay. So, to get your p-value, ito na. We can utilize your formula. So, equals CHISQ that inv. Yan. Class, ang maraming choices. Ito, CHISQ that inv. Yan. Quantity, 0.95. So, 0.095 is also the same as 0.05 at alpha level, class, or 5%. So, degrees of freedom. Paano kunin ang degrees of freedom? So, just count the number of categories minus 1. So, ilan ba yung categories natin? Hindi ba? 12. Diba? 12. So, Aries, 1, 2, 3, 4, 5, 6, 7, 8, 12. Minus 1 equals 11. Andito yan. K minus 1. To get your DF, degrees of freedom, K minus 1 lang. So, K is the number of categorical variables or levels. So, simply, 0.095, tapos comma, tapos degrees of freedom, which is 11. So, our p-value is 19.675. Yan. So, kung ayaw nyo mag-type ng CHISQ.inv and so on, we can use a table naman. Yan. So, class, get your degrees of freedom, which is 11. Tapos, at 0.05, so 19.675. Yan, same lang naman. Yan, 19.675. And simply compare your chi-square and your chi-square and your p-value. So far, naku class, so far nakikita ko may mga mali-mali sa greater than or less than. So, di ba kung saan yung malaking value, yun yung kinakain. Kung saan nakaharap si greater than or less than. Kung anong malaking value. So, mas malaki yung, yung 24. So, doon kumakain, di ba? Yan. So, class, meron tayo dito. Reject HO if chi-square is greater than p-value. Fail to reject HO if chi-square is less than p-value. Greater than, less than. Mas malaki siya. Yan. So, reject your null hypothesis. Yan. So, reject the null hypothesis. Therefore, we are in favor of the alternative hypothesis. So, class, dalawa lang yung choice, ha? Either reject the null or fail to reject the null. Ma'am, ba't ganon? Ba't hindi natin ginagamit yung term na accept the alternative hypothesis? Class, in statistic, what we can only reject the null. Yan. We cannot completely accept the alternative. Hindi natin siya completely ma-accept kasi we need more evidence to do so. So, yun, class. Reject or fail to reject lang tayo. So yun, reject the null hypothesis. Therefore, there is a significant difference. So in favor tayo sa alternative. Therefore, there is a significant difference between star signs on being a artist. Yan. So there is a statistical significance among our star signs. Yan. So it fits the prevailing expected values. Yan. So ganun, class, it fits. So yun. So class, ito ang conclusion natin. Yan. So please, as you can see, it's very organized. Sana ganun na rin kayong ka-organized pag mag-present ng answer. And class, I prefer that you paste it in PDF format para makomentan ko. Yan. Next, problem 2 tayo. So the manager of a car dealership, he did not want to stock cars that were less frequently bought because of their unpopular color, So, ang ganitong manager nito, class, ayaw na mag-order, he doesn't want to stock up on colors that are hindi mabenta. So, according to him, the expected frequencies or the number of customers choosing each color should follow the percentages of last year. Ayan. So, ito yung expected values natin. He now took a random sample of 150 customers and asked them their color preferences. So, we want to assess if there's a significant difference between your customers' color preferences from the present and from last year. So the null hypothesis is there's no significant difference between the customer's color preferences, and alternative hypothesis, there's significant difference between the customer's color preferences. So look at how I represented your null hypothesis, class. May mga mali pa rin dito. So equal sign po ang ginagamit. And alternative hypothesis, not equal sign po ang ginagamit. So your P1 is your red color based sa table natin. P2 is the yellow color. P3 is the green, proportion of green. And P4 is the blue. P5 is the white. So we have 5 levels of categorical variables. So pamaya kung kukunin natin yung degrees of freedom, so K minus 1, diba? So 5 minus 1 equals 4, yung degrees of freedom natin. Check conditions, check if the expected values, your total samples times the proportion is greater than 5. Yan. So to get your expected values, class, according here in our table, si manager, nakuha niya lang yung proportion from last year. So far from last year, 30% of the customers ordered red-colored cars. 20% ordered yellow, 10% ordered green, 10% ordered blue, and 30% ordered white. Okay? So class, here, so we need to convert it first to expected value. So pag percentage siya or proportion pa lang siya, kailangan natin gawing expected value. Ma'am, paano natin gagawin? So class, kailangan i-multiply natin yung small n times the proportion. So class, ano yung small n natin? So small n are the total number, the total samples. So pag in-add mo yung 50, 35, 30, 10, and 25, so ang result na dapat is 150. So simply multiply it. So 150 times 30%. 150 times this one, 30%. O, tapos i-drag lang natin. Yan. So class, so that's your expected values. May less than 5 ba dyan? Wala. So we can now proceed to test to step 3, which is test for your chi-squared. Yan. So very simple lang. So dito tayo sa column wherein there is observed minus expected squared divided by expected values. So equal sign. So observed tayo, 50 minus the expected, which is 45. So lagyan natin ng parentheses. Yan. Tapos lagyan multiply sign. Tapos same thing. Yan, 57 57. B72 minus B72. Yan. Don't forget the quantity. Ako, may dadali kayo, class. Pag kulang yung parenthesis, pag diretso nyo lang, divided by expected values. And ha, please. So, yan. Tapos, i-drag down nyo lang. Yan. Tapos, class, just simply get the total. So, sum of this one. Yan. So, 26.94. Ang chi-squared natin. 26.94. Yan. Please watch out for your, for your decimals. Papansin ko, iba-iba kayo ng sagot sa decimal point pag iba-iba yung round off nyo. Okay. Sa step 4. So, compare the value with alpha level at 0.05. So, class, cheese-q that I and V 0.95 kasi nga at 0.05. Different degrees of freedom is 4, diba? So, lagay natin dito. Is 4. Mampalan ko yung 4. So, levels. So, diba, red, yellow, white, 5. Minus 1, 4. Yan. So, our p-value is 9.487. Hanapin nga natin dito. So, 4. Tapos, at 9.488 naman dito. Yan. So, pareho lang. So, compare natin na, class. So, 26.94. Yan, greater than or less than 9.488 na lang. Yan. But it's greater than, your chi-square is still greater than. Mas malaki pa rin siya. So if it's greater than, so we will reject the null hypothesis. So reject the null hypothesis in favor of the alternative hypothesis. And so therefore, there's a significant difference between the customers' colored preferences. So it's statistically significant. So yung observed data, yung mga kinolect ni manager during the present time, and the last year's observed values are statistically significant. Yan. Class, meron pala akong note dito, hindi ko nabasa. Yan. So here, note if the observed values and expected values are too far from one another, the chi-square results becomes a larger value. Plus, pag masyadong magkalayo ang values ng observed, ano ba tayong magkalayong values dito? Pag masyado to, 29 at 40, pag palayo ng palayo, mas lumalaki yung p-value natin kasi ina-add natin, di ba? So, pag mas magkalapit yung value, ito ang layo, 7. Yung naging result, 3. Pag mas magkalayo yung value, yan. Pag mas lalong makalayo yung mga expected, tumataas yung chi-square value natin. Actually, mas nagiging statistically significant. Pag masyadong magkalapit, it's not becoming statistically significant. Yan. So, mas maganda yung result pag mas magkalayo yung value ng expected saka observed. Yan. So, class, I hope that you've learned something today. And I'll see you again, okay? So, stop recording. Bye-bye.